Hey guys, we're on 5, 6C, which is perpendicular line equations. Never know where to start myself. And our objective with this is to create and identify equations of perpendicular lines. So if you're not familiar with the term perpendicular, I'll go over that. But for now, this is an example of perpendicular lines. So I want to figure out what's the slope of these two lines. So I have it kind of set up nicely. I have a point here and a point up 1. So my rise is 1, and I have to go over 1, 2, 3, 4, 5. All right, so for one of my lines, the slope is 1/5. My other line starts here and goes to this point. I'm going to go do my rise first, but this time it's going to go down 1, 2, 3, 4, 5. So I go down 5. So that means my rise is -5, and I'm going to go over to the right 1. So here, these two lines are perpendicular, and I'll explain what that means in a minute if you're not sure. But their slopes, one of them is 1/5, and the other one is -5/1. Just think about that one. So perpendicular lines. These are lines that intersect to form a right angle, which is a 90-degree angle. A corner that we're used to, a piece of paper, and a corner of a square or a rectangle. All right, so any lines that form a 90-degree angle. So if I go back here, these do form a 90-degree angle, even though it's just kind of tilted a little bit. Here is a 90-degree angle. See, if I kind of straighten it out, it is a 90-degree angle, but I like it like this. Oh boy, I like it like that. I'm just going to do it to put how it had it. So lines that intersect to form a perpendicular angle. These are perpendicular, making 90 degrees. There's a special product, I guess we could say, for their slopes. The product of their slope is -1. Meaning if I multiply them together, I get -1. But backtracking a little bit, what that means is their slopes are opposites, which means one will always be positive and one will always be negative, and reciprocals. A reciprocal is when you take a fraction and the numerator and the denominator flip. All right, so they are opposite reciprocals if the slopes will be perpendicular, if the lines will be perpendicular. This is not true about every single intersecting pair of lines. This is if they are perpendicular. They will be opposites and they will be reciprocals. I'm saying this over and over again because I'm going to make sure you truly understand this in your assignment today. All right? If they're going to be perpendicular, they're going to be opposites and reciprocals. Okay? So this is very similar now to the work we did in our previous lesson, except we're dealing with perpendicular. So what is the equation of a line that goes through 4, -3 and is perpendicular to the line y equals 2x minus 5? The problem we had last section, it was parallel to it. Now I want to know if it's perpendicular to it. So if it's perpendicular to it, we must remember the slope will be its opposite and the reciprocal. So what would the slope of a line perpendicular to this line be? I'm hopeful that you said it was -1/2. My slope was 2. I need to make it the opposite, which makes it negative, and I do the reciprocal of 2, which is 1/2, so -1/2. Okay? So now let's actually create the line. We have a point, 4, -3, which was given, and we have a slope. We are going to do point slope. I plugged in my point, y plus 3, and x minus 4, my slope. And all I'm going to do now is distribute my slope to get -1/2 x. I'm going to distribute my -1/2 to the -4, which gives me +2. And I could drop down my y plus 3, but just to save myself a step, I'm going to end up subtracting that 3. So I get y equals, they cancel out, negative 1/2 x, 2 minus 3 minus 1. So this line right here is perpendicular to the previous line and goes through the point for negative 3. Special slopes, reminder for like the bajillionth time, horizontal line and vertical lines, they're just when y equals a number or x equals a number. Those are special slopes. They will be perpendicular. All right, they're not opposite reciprocals because the slopes are 0 for a horizontal line and undefined for a vertical line. So those are going to be the special ones. Let's do a quick example of that. What's the equation of a line that is perpendicular to y equals negative 4, which y equals negative 4 is a horizontal line. Oh my goodness, that is a very straight line. It is true. But it goes through the point 3, 5. So I want one that's perpendicular to this. If it's perpendicular to a horizontal line, that means I'm going to need a vertical line. And what is true about the equation of a vertical line? It's always x equals a number. So if it has to go through this point, what's the x value of that point? It's 3. So the equation of a line that's perpendicular to y equals negative 4 and goes to the point 3, 5 would have to be x equals 3. This line is perpendicular to that line and goes through that point. And that's everything. This assignment is another quizzes assignment. Please be sure to enter your first and last name. You get 2 attempts at it, and then the mastery check.